So next we have team Drop from Poland.
Thanks.
Are you ready?
Yes. Yes.
Okay, your presentation can start now.
Hi, I would like to welcome you to the CanSat drop final presentation. My name is Krzyś, and this is Jan, Jerzy, and Timon. We are also accompanied by our teachers and mentors, Jurek and Adam. This is the plan for our presentation: introduction, design, testing and results, finance and outreach, and conclusion. The goal of the primary mission is to measure temperature and pressure and send it to the ground station. Our secondary mission, of our own choice, is to perform a target landing. It could be used as a cheap way of precise package release and as a recovery system for model rockets.
Now we'll briefly discuss the design of our CanSat, particularly the secondary mission. There are two main components responsible for the secondary mission: our parachute and the servo motor. Our parachute is a twin-keel Rogallo parawing made out of ripstop nylon fabric. The parachute is composed of a single foil with two so-called keels in the middle, going from front to back. The parachute functions similarly to a paraglide, meaning apart from slowing down our descent, it also has a forward velocity and is capable of turning. The parachute is suspended on 36 cords, 6 of which, so-called brake cords, are attached to the aforementioned servo motor in two groups of 3. When the servo motor rotates, the difference in length of the brake cords causes the parachute to turn. We have done many tests with this system, and during the national finals we unfortunately couldn't reach the targeted location because the wind speed at the time equalized with our forward velocity, which was about 5 meters per second. We've since made improvements to the system and mainly decreased the parachute size, and yesterday we've got results better than ever before. Now let's talk a bit about the software side of the steering.
Using GPS, our CanSat calculates its optimal heading. Using magnetometer data, it calculates its current true heading. Knowing these two values, it calculates the difference, which shows how much and in which direction to steer. Knowing that it has a 10-degree dead zone in which it doesn't steer, and outside of that dead zone, it steers towards its target. Now we will talk about testing and results. The first chart shows the difference between temperature recorded by our Dallas sensor outside the CanSat and BME 680 sensor inside. The x-axis shows the number of packets from the beginning of the chart, which is approximately the moment that CanSat was released. As you can see, the difference was about 10 degrees Celsius throughout the duration of the flight because of the electronics heating air inside the CanSat. Due to an undetected software issue, BME was recording once every 4 seconds and not 5 times a second as expected. The next chart shows both recorded pressure and altitude. Altitude is in meters above the point of calibration, which is approximately the ground. On the x-axis, we have the number of packets from the beginning of the chart, which again is approximately the moment CanSat was released. The CanSat flew to about 850 meters. And after that, it descended fairly steadily until it landed. This chart shows the recorded temperature and relative humidity. The axis is the same. On this chart, we can see that the temperature. On this chart, we can see the temperature dropped when the CanSat was released.
The animation is buffering, unfortunately, but in this animation, it's playing now. In this animation, we can see the recorded flight path, GPS flight path of our CanSat, as well as its correct heading. The red arrow, which you will see in a second, shows the desired heading of our CanSat, and the red pillar visible in the distance, sometimes, marks the desired landing location of our CanSat. The camera, meaning our point of view, is located behind and slightly above the CanSat. Please note the animation is sped up for the purpose of this presentation. After falling out of the rocket and deploying the parachute, our CanSat started controlling the direction of flight towards the targeted point, which was located at the end of the airport runway. During the first moments of descent, our CanSat was spinning very rapidly before it regained control, which is visible here, should be visible here, and was also reported by our observer on the ground. Once CanSat was in close proximity to the targeted point, it started revolving around the point and finally landed just 28 meters away from the targeted point. We measured that distance on the base of the recorded GPS data. Now let's talk some more about our secondary mission data.
On this chart we see both the heading and the optimal heading of the CanSat. Both optimal and true heading were calculated with data logged by our CanSat using the same methods as our CanSat. As we can see, the heading oscillated around the optimal heading, which is caused by the dead zone of 10 degrees that was mentioned before. In the first part of the chart, we can see a lot of turning, which is consistent with the observation of our observator on the ground. On this chart, we see the length of the vector of acceleration recorded by our CanSat. This chart starts about 100 seconds before the other charts in order to also show the acceleration recorded during the start. This chart shows a side-by-side comparison of heading and acceleration starting at the moment of CanSat's release. This shows that the flat part of acceleration of about 20 meters per second squared was probably caused by high rotational speed of the CanSat. It is also visible in a few smaller spikes on this chart. After the national finals, we also designed an automatic antenna aiming system. Unfortunately, we were unable to test it yesterday due to the sudden nature of the launch. However, before the launch, we could see our antenna tracking the rocket. We had a backup plan, which was to use a PS4 controller, but due to its long startup time, we deferred to a fully manual approach.
We'd like to take this opportunity to thank our sponsor, partner, Lot Polish Airlines, who agreed to be our official carrier. Now we will talk about finances and outreach. During our project, we gathered in total 11,811 PLN, which equals to 2,652 euros, and spent 1,746 euros. Our cost of one CanSat is 154 euros. In total, we reached throughout our project 460,000 people. That's our estimates, mainly from our businesses in the biggest TV station, private TV station in Poland, TVN, the biggest internet radio station in Poland, Radio 357, on our school open days, and in 3 primary schools. We have also created an Instagram account and a fundraising account on pomagam.pl site.
To conclude, we find our primary and secondary mission very successful. Throughout the whole flight, we maintained a stable connection with the ground station and landed 28 meters from the designated point, which is within the previously stated goal of landing with less than 100 meters of accuracy from the designated point. Finally, we are very happy and greatly honored to have this opportunity to present our project here at Grenada at this event. Thank you for your attention. We'll be very happy to answer any questions.
Excellent, a clear presentation and right on time. Let's see if the jury has questions. Yeah, for sure, you have some.
So yeah, really nice, successful secondary mission there. So I think to me that proves the aerofoil shape and the control mechanism for a CanSat-sized payload. Do you have any idea on whether that could be scaled up?
Yes, we think it is possible to scale the system up. In fact, a few decades ago, NASA tried designing such recovery systems for manned rockets for the Gemini spacecraft. But NASA stopped testing with that idea. But we think our mission yesterday proves the feasibility of this system, and that with today's technology, the system could be scaled up again to serve as a recovery system for manned spacecraft.
Is the shape based on an established kind of aerofoil design, or?
Yes, this is the NPW5. That's what NASA calls it.
Brilliant. Thank you.
Thank you. It's really nice to see always successful missions or the launches of the CanSat. So we see a lot of successes, but what is the most important lesson learned?
I think the most important lesson learned was to not overcomplicate things, just to simplify them, not to add any unnecessary features that could prevent our mission from being successful. So we didn't wait for the last moment to change some things. We tested everything before we went here, and we knew that it would work.
I wanted also to add to double-check everything, because we had the BME issue that I mentioned before, and it could be avoided because it was software issue. I don't know why, but we didn't test for the frequency that it collected its data, so that's a thing that we should have done and we will do in the future.
You mentioned that you didn't hit the target because of the speed of the wind. Can you now characterize numerically up to which level it will work for future missions?
Could you please
sort of
specify?
characterization, you know, I mean, this is a system that can guarantee, double quotes.
Yes, so the system with this model of the parachute is able to land closer than 100 meters to a target point with winds of up to 4 meters per second, which was proved yesterday. And we would need more tests to find the limit of this possibility.
Okay. Okay, I think it's enough. Unless you want to add something, you really have 1 minute more on the outreach, because we stopped you.
Yes, so we were mentioned in a couple newspapers. We gave an interview to one of the big radio stations, RMF24. And yes, we reached a lot of people, and we are very happy. And all the presentations in primary schools we've done to help.
To promote the CanSat competition and generally STEM projects, because...
Have you already informed your
interesting.
sponsors?
Pardon me?
Have you already informed your sponsors? You showed how much you got from the sponsors. Have you informed them about the result of the mission?
No, not yet, because yesterday we focused on the data analysis, but we will do that certainly.
Okay, perfect. Thank you very much for the presentation.
Thank you.
Excellent result.
Let me see what we have in these papers. Yeah. Now, the next prize shows and demonstrated the struggle of the jury. We have a small hiccup because for the next prize, which is the honorary prize, it's a special prize which goes across all the categories. Special mention, special dedication, honorary prize. But we brought one from the Netherlands to deliver to the winning team, but we have two winners. We could not decide which one of the two was the only winner. So we decided to give two prizes. The hiccup is because one team can go home with the prize, the second one will receive it by post in the next days. So are you curious to know who they are? Certainly not the teams that you have already seen, because one of the rules is that one team, one prize maximum. But this is a very good performance across the whole spectrum of abilities that you need to have a good CanSat project, from science to outreach. And the good performance, which has to be rewarded by the jury for the two teams. I say them obviously in one order, but it's not one first or one second. They are both equally ex aequo deserving this prize. So I would say them in a quick sequence. The honorary prize this year goes ex aequo to Poland and UK. You decide who brings home today. I leave it up to you, but I would like one spokesman. You?
I would like to thank the jury and everyone who organized this event for the very nice organization, very nice event, and also every other team for being here, for competing in a very nice way, being very nice. Thank you to all of you. You want to say something?
I think I speak for my whole team. It's same. Thank you for the judges. Thank you for all the staff. The time here was amazing. I'd also like to say thank you for our mentors, Mr. Hunt and Miss Roberts, who have been sticking up with us for 5 days, and that's a bit difficult. And I'd also like to say thank you to our teacher, Mr. Hodge. Unfortunately, he did pass away while we were building our can, but we think we are done and proud. Thank you.
Also, we will also send you certificates for each of you, okay? With the winning certificate. So don't worry about that as well.